Welcome everyone. Today we have our another new episode, and this is part of our summit, Talent Economy Summit. Because World Talent Economy Forum, we do more focus on talent economy, and we have a lot of good news. We have our world famous speaker, Professor David Smith, Professor Rob, and Professor Donald. So we will discuss about artificial intelligence and ethics of artificial intelligence. First, I want to give chance Professor David Smith.
Sharif, thank you for a very important topic today. Uh, as you begin to look at what's happening in recent times, the explosion of information globally from a wide variety of sources and purely computer generated technology have produced techniques such as the deep fake type of information that's made it really very important to check on the credibility and reliability of data. And when I look at the tremendously large volumes of data generated from the information channels like social media, online news outlets, crowdsourcing material, things which are coming out of governments and political parties and others like that, it becomes very important to look at how you ascertain the credibility of both the user generated and the machine generated information that's out there. And there's a lot of technologies in the general domain of artificial intelligence beginning to be applied to this. And you see the natural language processing. There's something called natural language claim text. Uh, there's this structured triple and social next context. You have these whole multimodal sources on how do you identify the high quality and trustworthy information sources, and how can those be manipulated. We know as we looked at many of the things around elections, not just in the United States but worldwide, we see this going very forward. There was a survey done recently by IBM, and it came back and it said that 91% of organizations say their ability to explain how their artificial intelligence applications made a decision is very important to that information being acted upon in good faith. You know, we as human beings traditionally over the years hate what is commonly referred to as a black box decision, where you put stuff in and it gives you a decision. You have no idea how it was weighted, how it was formulated, how those pieces come out. And if we look over history, we see time and time again where those things have come back to us. But so a big area of work today is in the trustworthy AI technology areas. And this trusted AI technology must reflect characteristics such as accuracy, explainability, how it is interpreted, privacy, reliability, robustness, safety, and security, or resistance to attack to ensure that the bias is mitigated. And factors such as the fairness and transparency should be really considered when you look at how the information is used, how it's deployed, what type of decisions are being made with it, what type of autonomous decisions are being made with it. And it really goes in there. One of the places this also interfaces is with the body of knowledge today built around ethics and artificial intelligence, because the trustworthiness and the ethics go hand in hand as you're beginning to trust decisions that are made by artificial intelligence, not just those that aid humans, but those that, particularly as they begin to do autonomous actions on their own. You know, some of the classic examples is if you're in an autonomous driven vehicle, would you run over a mom pushing a baby, or would you run into a group of people? And how do you begin to make those types of decisions? How do you begin, if I'm a combat drone, to decide whether I use lethal force without the aid of a human in the loop? So those are some of the places where this technology really comes back to play, how it's used, and whether the artificial intelligence that is being used is trustworthy for the types of decisions being made around it. So Sharif, hope that's a good high-level intro.
Thank you, Professor David Smith. Professor Rob, how you want to analyze the topics and how you want to share some of the experience from industry.
Well, the underlying concept of ethics and morals is a difficult subject, a difficult philosophical subject to cover. The rules that govern our behavior are thought to be morals. Ethics are the study of those rules, and David Smith talked a little bit about compliance. This is the idea of when we talk about AIs, it's the idea of creating machines that do no harm, that will enhance the human race, not detract from it. There are a number of ethical efforts going on all over the world. China's Ministry of Science and Technology has issued guidelines on artificial intelligence ethics, and those guidelines stress user rights, data control, and also include reining in big tech for whatever reason, because those are the rules that they want to be adhered to. And China is actually trailblazing this effort. It's kind of interesting. As far as a country, the European Union has also been pretty aggressive here. They've got a preliminary draft of AI-related rules that came out in April 2021. The final, though, hasn't been released yet. And in the United States, it's received some traction, but it really hasn't gone much farther than that. David also mentioned IBM. IBM is probably the leader in the U.S. industry with regard to a focus on ethical AI. And they have exited some of the businesses that they thought were behaving unethically, like facial recognition. IBM exited that business because they felt the technology was being abused and misused, and it violated their own ethical guidelines, and they exited the business as a result. It wasn't because of profits. It actually, because the business was fairly profitable, but it was because they violated the ethical guidelines. Asimov's laws, 3 laws of robotics, fall within these ethical constructs. The idea that robots can't harm humans, even through a mission, and that their own self-preservation is subordinated to that first law. So this concept of ethics goes back decades in science fiction, but it's only recently been addressed by the governments of the world. And as I mentioned, while China's leading in the ethical discussion, clearly they've got a bit of a twist to it, which attack mostly U.S. tech companies. And the European Union's made some progress, but hasn't confirmed. And the U.S. is kind of struggling at the moment. The idea of having ethical AIs is incredibly important because if you recognize that artificial intelligences can make decisions at computer speeds, which means any human mitigation would probably come too late and be ineffective. And so you want the AI to act responsibly, because our ability to correct mistakes the artificial intelligence generates is severely limited. If you were to look at just how quickly AIs work in the financial market, for instance, they're making decisions in microseconds, and people don't. In fact, one of the reasons why cryptocurrency right now is struggling a bit is because it takes about 10 minutes for a cryptocurrency transaction to complete, which is way too slow for most transaction types. So that's why folks are a little concerned that where it is being used fairly aggressively is for criminal endeavors, because they'll tolerate that kind of timeline in exchange for anonymity. But in crypto, even the anonymity hasn't held up very well of late, which is probably one of the reasons why crypto is so volatile, though there are a lot of other reasons as well. So finally, this is an important subject. It's something we should have addressed long before we started creating artificial intelligence. We are playing a game of catch up, and we should have a worldwide accepted and enforceable set of ethical rules that are in place. And even in China, where they're the most aggressive, they're more suggestions than they are rules at this particular point in time, suggesting that the world is well behind where it should be as we advance artificial intelligence and we look at deployments as in areas like military, finance, healthcare, and even governance. If we have AIs that are acting against the greater good, we're going to have serious problems, and we have not created enough mitigation to prevent that from happening. So it's important. We're not where we need to be, and it's not clear we'll get there anytime soon.
Thank you, Professor Rob. Professor Donald, I want to give some good example from industry.
There we go. Well, David and Rob laid the groundwork very effectively, and I really appreciate that. And so I want to take a second and talk about what AI actually is, because I think I've been really researching this recently, and there is so incredibly much hype that we get confused. I don't know if you've been around long enough, but it wasn't that many years ago, certainly 5 or 6 years ago, well, maybe a little more, that speech recognition was so bad, it was pretty much useless. You could train it, but it would constantly make mistakes. If you had the slightest accent whatsoever, it couldn't understand anything that you were doing. And what really made the difference is what's called deep learning. And that term is very deceptive, because deep learning isn't learning in any particular way that we would really consider learning as human beings. It's one of the things that we do is we apply terms that apply to human beings, and then we apply these terms to artificial intelligence, and then our brains anthropomorphize it, just like we can imagine our cat is understanding everything we say, and when the cat does something, it's doing it because it's making decisions in the same way humans do, and we know that really can't be possible. So deep learning, to put it simply, classifies things. So a deep learning system will be taught, a person marks on a photograph, say for an instance, this is a face and this isn't a face, or this is a lamppost, or this is a dog, or whatever kind of thing you're trying to classify. And then they feed that into the system, and the system starts developing probabilities on whether or not, when it sees a new photograph, what's the probability that this particular pixel in the photograph is a part of a dog, or this particular pixel in the photograph isn't part of a dog. So it's basically simply training these by repetition, and basically what's called, basically by structured repetition, it's figuring out what things are. Now, that doesn't make any decisions for you at all, really. The decision is made when you see, after the classification is made, you decide what to do based on the classification. And that's where it really gets sticky. David brought up what's called the trolley problem, which is a fun problem in ethics. And the idea, it's very old. It's because just you think the name trolley, it's probably pretty dated. And the idea is a trolley is going down a track, and it's about to hit a group of people. And there's a switch in the trolley, so the trolley operator can throw this switch. And if he or she does do that, then it'll change direction and go down another path that'll kill just one person. And so the question is, would you throw the switch or not? And then, the question there gets, because then it's the person's deliberately killing the people. And if they don't hit the switch, then it's just fate. So there's no real solution to that problem. I mean, it's something that we discuss and we try and understand, and it brings out the idea of what's called utilitarianism, which is the idea that we do the things that are the most useful and we make decisions based on the greater good, is one of the ways we do it. However, the point I really want to make out of that is that for every circumstance, there needs to be just multiple decisions. And it's really important to realize that the AI is not making those decisions. And right now, pretty much the only way we can do it is to make lists of rules. And so there's so many decisions we have to make that we paint ourselves, we just can't do it. It's not, AI can't really learn how to make decisions. For an instance, I want to say that search engines now, especially Google, Google and Bing both use AI, and what they do is pattern recognition. So what they do is they look at the string that you input, and then they take that string and then they output a string that or information that allows it to do the best possible search. And they're doing it on the whole string. They're not doing it on they're not breaking it down into words or into tokens. They're not searching for keywords. They're searching for the whole string. Okay, and so it gets trained with all the people that are using Google, all provide information, and then they can tell whether it's good information or not, or useful, by what the person clicks on, because it comes out in a hierarchy. There's, the first thing, the second thing, and so on when you get the search results from Google. And if they click on the first thing, then that teaches the AI, well, if you classify this string in this particular way, then it's the most useful for people. So again, it's just classifying, okay, and then making a decision based on that. And an example, just to show how bad that is, I'd recommend that you go to Google or Bing and you say to the question, show me all the coffee shops that aren't Starbucks near me, okay? And because it's just comparing patterns that aren't in there gets ignored, because that's very rare for people to actually make a request like that. And what you'll do is you'll get a list of the Starbucks that are near you. It won't see that negative, that negation, because it's not breaking it down into individual tokens. It's looking at the entire string. And machine translation seems wonderful too, but again, what they did is they just took, say for instance, French, and they took a whole bunch of French and a whole bunch of English that was a translation of the French or the other way around, and they trained the system so that the sentences that it gets are most likely to be a certain sentence in the other language. And it does a pretty good job of that. It makes some real funny mistakes. Like I have somebody that's been sending me stuff in Russian, and it comes out pretty bad in English. And so again, it's not really making any decisions. It's just looking at patterns and probabilities. So where that gets to be a problem is, first off, we don't really know what's going on, and we can't really tweak it in the ways that we'd like to. So that question of negation in artificial intelligence is a very difficult question. Researchers did think, and looking at self-driving cars, which are, there's a lot of hype about that. For instance, I saw a headline the other day that said, Amazon is using self-driving trucks. So if you read the article, what they're doing is they're using self-driving trucks on a fixed pathway between warehouses with no other vehicles on them. So the gap between that and you driving through Istanbul in the rain is so incredibly huge that there's no relation between the complexity of the two different problems. So we're a long way from self-driving cars, but that to what I'm saying is that because we're just recognizing these patterns, what we do is we come out with what's the most normal. So when we're doing credit checks, for instance, we have to ask ourselves the question, what's the most normal transaction that this person would do on a credit card? And you train it. And then if somebody does something that's very different than the most normal transaction, then it flags it and says, well, there's probably something wrong with that. If we start using that on people, then all of a sudden we run into huge problems. So that's Rob mentioned that facial recognition had been abandoned mostly, and that's simply that can't work. We can't emotion. There was this idea at one time by this guy named Paul Ekman that we had basic emotions, and that everyone in the world smiled when they were happy, and everyone in the world frowned and made certain expressions. And that was, his data is wrong. He didn't share his data. No one could duplicate it. And eventually people found counterexamples and realized that that was baloney. And I won't get into how emotions work right now, but we can't look at a person walking through an airport and say to them, we can't look at a person and say this person's lying. So what we're doing is normalizing things so that we're dealing with the most average person and trying to get it so that people are all the same. And I'll talk more later about why that's really a big problem. And that's what I want to lay a foundation.
Thank you, Professor Donald. Mr. Adam, can you hear me? Mr. Adam, can you hear me? Okay, in that situation, I want to give chance. Mr. Adam, can you hear me? Adam, can you hear me? I cannot hear you.
Hear me now?
Professor David Smith, I want to give chance Professor David Smith because there are many questions from audience. I want to take questions from Mahadi.
Great question.
Okay, what are the major challenges of AI?
There's quite a few in AI. Let me just kind of hit some of the top ones to go there. If I were to look at the top challenges, is one of them is how do you build trust? AI is related to science and algorithms and really are very technical, and people have a difficult time understanding its functioning. So how do you build trust? What is the human interface, the AI human interface there? Most of the time we see that the human sees more of what's happening. That is not always true in artificial intelligence. Again, a different study that was done by Deloitte showed that 55% of surveys felt the biggest challenging was the changing scope of human jobs and interactions with the systems when artificial intelligence was applied. Another one is investment and how you see that. Another one is the fact that AI cannot replace every task and that you have these really high expectations there. There is a dramatic fear of what happens when the software malfunctions. With these large programs in the different areas of machine learning and applications of AI, it's difficult to identify the causes and mistakes which are happening there. And the last couple, though, are in artificial intelligence. Depending on how you train the AI, there's biases that are introduced in the algorithms. And how do you tackle that? How do you understand what the biases are? How do you see that artificial intelligence is biasing the answer that it's giving to you, or is it an inaccurately corrected model that inherits a society biases or statistical errors that are in there? So that algorithm bias is one of the other big challenges. And finally, the other big challenge of artificial intelligence is, how do you hold it accountable? How can you say that the machine language that was used to generate the artificial intelligence, is it accountable? Because oftentimes AI will develop it beyond the initial task that any human developer had as they were beginning to write it, as they continue to learn, as they continue to self-learn. And so that accountability is one of the other major challenges of AI, and ones that have to be tackled to really understand. So those are about the top 8 major challenges of AI.
Thank you, Professor David Smith. Professor Rob, if you give this answer. Yeah. Nur Fazrin, what policies help to improve the error that have been made by artificial intelligence?
Well, when you say what policies, as I say, there's a set of ethics efforts that are occurring in China and the EU to address these kinds of problems. The issue with regard to facial recognition was kind of interesting, because it wasn't as a result of people wanting to make the technology working correctly. It was the result of using flawed data sets. The initial data sets that were used, because the scientists that were creating the facial recognition AIs were pretty much old white guys, and because that's who was doing the work. And they kind of showcased the lack of diversity in AI development efforts. The end result was, and what had been used before to identify were animals. So the data set contained a fairly deep understanding of animals and a very limited understanding of humans, and humans were largely defined as old white guys by the AI. It wasn't by intent by the research group. It just, that was the data they had. And then if you had somebody that wasn't an old white guy, it did some pretty ugly things. It might categorize you as an animal, particularly if you were female, because there weren't a lot of women in the data set, white or of various minorities. And the end result is you had a biased data set, and a biased data set can destroy an AI's capability. Don talked about the fact that AIs don't make decisions. That's true in some cases as we interact with them, but the fact is they are making decisions in many places where they've been deployed. There are classifications of AIs. Where we are right now is called narrow AI, which is where you have an artificial intelligence that's focused on doing a specific task, like recognizing a person. And where we're going is general AI, which is an AI that can do a variety of tasks and to a large extent be used in place of a human. We're not there yet. There are a number of trials that make it look like we might have some of the first really good test cases early next decade, but that seems to be the earliest for general AI breakthroughs aside. One of the areas where AIs are making decisions on a regular basis is with autonomous machines. We have autonomous robotics in place. Autonomous farm equipment has been released by Kabuto now, and John Deere has their architecture coming forward as well. And these are machines you could set loose on a field, and they'll continue to do the work that they've been dedicated to do, and even selectively put fertilizer or poison for weeds where it needs to go very, very accurately, largely because the data sets that these machines are trained with were in some ways very simple and also in many ways complete. Don also talked about the difference between machine learning and deep learning. And it's an interesting discussion. Machine learning is really where the data scientist defines the rules that the AI follows. With deep learning, the AI to a large extent makes its own determination without a data scientist involved, except for error correction. But the big problem with deep learning is it requires massive data sets. I mean, the data sets are magnitudes greater than what you need for machine learning. But as they say, you don't need the people involved. So in some cases, it works better, particularly where you already have those big data sets. And deep learning is really where much of the medical research is being focused, and why the problem has arrived with regard to data access. Let's see, we have some more questions. See, how can the developed nations prevent the collision that is being created by? I'm assuming you mean the collision between human ethics and machine ethics, or between human workers and machine workers. Like most things, the developed nations tend to look at a problem after the problem has become pronounced. Right now, the problem is not yet pronounced, so they haven't done a lot of work on it. And of course, the real concern comes when you're using AI for defense, for weapons, is that the way we're going to find out it's not working right is undoubtedly because it's misbehaved. And when you're talking about a weapon system, that can be problematic. So we are not at all where we need to be with regard to preventing a Terminator-like event. Good news is we don't have Terminator-like capability yet either. The bad news is we're rapidly working to create it. Do we trust an AI anthropomorphism and intelligence? I would say it depends. It depends on how well designed the AI is. It depends on the data set that it was programmed with. It depends on the capability and ethical guidance of the data scientists that create it. I would say generally with AI, it probably is more of a trust but verify. They aren't inherently good or bad. But right now, allowing an AI to function in a critical area without oversight would be incredibly risky. We just do not have the mechanisms to address an AI that's off the rails. There have been, by the way, there are a couple efforts. AI Shield. There are 2 AI Shield efforts. One by the Lepo Foundation, another one that Google's working on. To create, with the concept of creating an AI to defend against hostile AIs, which may be the only way we could defend against, say, a rogue weapon system or an AI that suddenly was decided to do ugly things with regard to infrastructure, which is the other area I think a lot of us are concerned with as we deploy AIs, because infrastructure, particularly power and waste management, water management would be an ideal place to put AIs, though we've certainly saw with the incident in Florida where a hacker went in and made adjustments and was luckily caught that if one of these automated systems gets compromised, that it could kill an awful lot of people really fast. So it's probably a mistake to anthropomorphize an AI. At this point, we're not anywhere close to having a human AI in any case. And trusting an AI without having some type of control structure around it to catch and identify an out-of-control AI would be exceedingly dangerous and could cause a lot of problems. Donald also brought up the trolley problem. And the trolley problem is kind of fun because it's been misapplied in terms of autonomous cars. The autonomous car version of the trolley problem is a car is coming at speed, and it has a choice to make between killing a bunch of students in a crash bus or hitting the bus and killing the driver and killing the AI. And what's the AI going to do? The reason it's a false problem is AIs as applied in autonomous vehicles are trained not to overdrive their sensors. And if you look at how a problem like this might occur, it would be because a human driver, and human drivers of course do this all the time, is driving too fast for the situation. So comes around the corner at speed, suddenly sees a bus with students and off it, and then the driver has to make a decision. In almost all test cases, the driver cannot make the decision. Human driver cannot make the decision fast enough, and will go wherever the car is pointed. The ethical issue for the human driver is a non-issue because the human just can't make the decision fast enough. And the car, by the time the human makes the decision, is undoubtedly ballistic anyway, which means the car is exceeded the ability for the control structure to control the vehicle. With an AI, that never happens. The car will not overdrive its sensors. The one exception to that would be if the car, for instance, hit ice and was unaware of the ice that it hit. But once again, in that case, the AI is ballistic. The vehicle is ballistic. It doesn't matter what the AI decides. The car is going to go wherever it's pointed because, again, the control surfaces cannot control the car in that instance. Though there is a better chance that an AI, knowing that ice was in the area, would be driving at a far slower speed and is less likely to have the catastrophic accident that we as humans do. I live in an area where we do get black ice, and every year people are found killed because they've overdriven they've driven too fast in areas where they shouldn't be driving, where they should be driving very slowly, and had an accident as a result. An autonomous car will not do that unless the human driver overrides that capability, and so that wouldn't happen. And so, most cases, the examples being used using the trolley model, the trolley model to apply to an artificial intelligence car, it's a false argument. The artificial intelligence car, the autonomous vehicle, will not be in that situation as often as a human driver would, and virtually every model that's been run, and we're now running these things in large simulation, would indicate that the artificially driven car will end up better than the human driven car, predominantly because it doesn't overdrive the capability of the car to correct itself. So let's see, any other questions we've got here? I think that was the last one that we had. Sharif, was there another question you want me to address? I already did the anthropomorphism and intelligence one.
Yes. I believe all of the question answer you give. Thank you for your excellent response for our audience. Professor Donalds, what you want to actually, Professor Rao cover all of the question answer, but definitely you can add.
Well, Rob made some excellent points, and as we talk about the trolley problem just because, the question is which decision is the right decision, and different people will have different views on it. And what I want to go back and emphasize is I think that it's a mistake to say that artificial intelligence is making decisions. What artificial intelligence is doing is giving you the probabilities that certain things are true or not true. I mean, truth is what the artificial intelligence decides. And then human beings have to decide whether the information they get from from that classification, you're going to make some decision based on that. So the decisions that Rob made the distinction between deep learning and other kinds of artificial intelligence. One of them is based on patterns, basically classifying things, and the other one is based on rules that once you know the classification, you decide what you're going to do with that information. So at some point, somebody's had to decide what they're going to do with the information that comes from the classifications. And so that's why I say the AIs aren't really making the decisions. They're basically following rules that we programmed into them. So I think the idea of general intelligence is an example of anthropomorphizing things that, and the question I would ask everyone, that's listening is what is intelligence? Now, we have this whole idea that we can give people intelligence tests and find out how intelligent they are. That's a fairly recent idea. It comes from a guy named Benet. And they asked Benet once, what is intelligence? And he said, what my test tests for. And so it's something that we use to explain behavior, but it's not really something that is agreed on to what it could possibly mean for it to exist, for there to be such a thing as intelligence. Psychologists today talk about 10 kinds of intelligence, and they talk, the kind of intelligence that it takes you to become a good musician is extremely different than the kind of intelligence to be a good architect. One is visual, the other's auditory. They are processed in different parts of the brain. They're very different. And when we talk about general intelligence, I want to point out that if AI had good general intelligence, then it could actually use and understand language. But as I pointed out right now, it's not even anywhere close to actually understanding language. It's just looking at patterns and finding matching patterns, basically. That's all it's doing. And I think that it's worthwhile thinking about like what a child knows. Very young child, 6 years old, 5 years old. Is a chair something you can look up in a dictionary and find its meaning? Because for a 6-year-old child, they know that a chair is something that they can climb on to get cookies. It's something that they can put a blanket over and make a fork. They know that if they draw on it with crayons, mommy's going to get mad. I mean, what they know just about a chair is so incredibly vast that we can't really categorize it. And if we could categorize it, we would still have every other object in the world to categorize, and then some sort of a way that they interrelated to each other, like the example I just gave, the interrelation of the blanket and the chair. It's possible that there's a place where kids can draw in crayons on chairs. Their grade school or wherever. So the rules about when you can do those kinds of things vary by different kinds of contexts. How could we define and understand every possible context? Because as Rob pointed out, the way deep learning works is you just train it with lots and lots and lots of data, and it winds up knowing just one thing. Like if you are trying to recognize two different faces, you have to train it to recognize one face and then train it to recognize the other face. And then you ask the question, basically it pops out, and in one case it says, yes, this face is there, and in the other case it says, no, this face is not there. Or if you have two different faces, it's just basically a yes or no answer. And then the artificial intelligence can do something with that information. It can find the faces in your picture on Facebook and group them together or something like that. But we're so incredibly far from the idea of general intelligence that we've made no progress at it at all, I'd basically say. And I think it's not something that we're going to have to worry about. But back to what I'm saying is Rob gave a good example about the facial recognition, recognizing African Americans as gorillas right at the very beginning, which was very not popular, as you can well imagine. Another example I want to give is Amazon got this brilliant idea that what they were going to do is they were going to look at all the resumes that came into them, and they get a lot, and they were going to compare the resumes to their best employees. And what this was going to allow them, by just feeding resumes into the machine, to pop out the resumes that were most likely to have people that were going to be good employees. Well, it's almost exactly the same as the example Rob gave. What happened was that the best employees in Amazon were all fairly young white guys. They were all basically fairly well off to go to the schools they went to and things like that. So they had a background where they were encouraged to be engineers and went through the trouble of becoming engineers and all of that. And so what it was doing is there were virtually no women working at Amazon. and there was no people of color, and there was nothing. It just made their situation worse. And people have different opinions about diversity, but the actual research, the actual evidence shows that diversity is absolutely important for creativity. It's necessary. So Amazon was putting themselves into a situation where they were basically cutting off the kind of creativity that they needed to be successful. Plus, the optics of that are pretty bad. So they stopped doing that. But to the degree that we're doing that, it's influencing our whole society. So US News and World Report ranks universities, and they've gotten better, and they did it by hand, but now they're using pattern recognition and AI to do it. And so one of the things that is important to understand is what's really special about deep learning is what's not special about it is what they're doing is the same kind of statistical analysis. The major portion of it's regression analysis. And if you've ever seen a regression equation in linear algebra or different partial differential equations, you know that basically they're just a whole bunch of variables added up with weights. And you solve the equation and you get either 1 or 0 in the case of most AI. And what is allowed to happen is that you can have literally billions of variables. There's over 1 billion variables that are being used in speech recognition now. And one of the people who made that technology wrote some articles on it about how terrible she thinks that is, because there's no way that you could figure out whether an equation of 1 billion variables was right or not, especially when it's happening in, they can do more calculations and more, and basically the way it works is is that it iterates, and it basically has a curve like that, and it iterates to try and find the point on the curve of the most highest probability. So it's not only just using 1 billion variables, it's using them and changing them over and over and over at practically light speed. And so we can't know what deep learning systems are doing. And then back to what I was saying about the universities. Well, universities wanted to be the highest ranked, so they guessed which variables in those equations were the most important, had the highest weight, and would change the outcome of the approach, and actually change their universities to fit the models that were developed in the deep learning system. And then the consequence of that is that people who were trying to get into those schools realized which things were the highest weight, and wealthy people could hire tutors and experts and do training sessions and everything else like that to make sure that their kids were better at the things that were the most important according to this linear equation. And it basically started just selecting for wealthy people, who, not so much intelligent people, but wealthy people. So when you look, and from what I just said, if you're looking at intelligence, what I just said was that it's selecting for wealthy people, not intelligence. So intelligence then becomes defined as wealthy people, because that's what is being tested for. It's, as Benet said, that's what's being tested for. And I think that the idea that there's going to be artificial and general intelligence, Geoffrey Hinton, who invented deep learning, thinks the idea is absurd. And I can go into many, many reasons why it is absurd for hundreds of years. And so that's not something, we don't have to worry about robots suddenly getting intelligent like Skylink and Terminator or something like that. That's not going to happen. But using artificial intelligence and taking the decisions that deep learning is making And using those decisions to actually do things with people in the real world is what the danger is, because we can't know what it actually is that they're doing to make those decisions. And just to finish that up with autonomous vehicles, the engineers found that if they taped Post-it notes to stop signs, just put Post-it notes on it, it would completely baffle the pattern recognition of the deep learning in the autonomous vehicles. So we're so far from any of this being intelligent in any way. The danger really is a matter of, using the wrong training data. And the question is how do we get the right training data? We don't even know that it's a problem until after we've trained it and it doesn't work. So I think that looking at this realistically is probably one of the best things to do to get over the dangers that it might cause.
Thank you. Mr. Adam, can you hear me?
Yes, can you hear me?
Okay.
Yay!
Oh, finally. Jeez, I'm so sorry. I have no idea. Well, never mind. Oh, thank goodness. I was worried I'd never get to do these again. So, yeah, as Mr. Donald quite rightly mentioned, there are different types of intelligence, of course. So, AI, artificial intelligence, is a somewhat vague and probably quite primitive term. And I think before AI, it might be more appropriate to figure out ways for humans to enhance their own intelligence, faculties, capabilities, reasoning. It might not be possible to create AI from scratch for the foreseeable future. So I think maybe we would benefit more from enhancement, because the resulting intelligence would then be less alien to us than what we could envisage AI to be. We have so much knowledge by now. We may need to rely more and more on neuroprostheses like Neuralink, and tackling existential risks will require massive knowledge base. So, and humans are too specialists nowadays, and we need to synthesize huge knowledge bases. And another thing that concerns me is like the widening of the intelligence gap that AI could cause. Big discrepancies in intelligence can lead to intensified animosity. I noticed there's a kind of a messianism within like singularitarianism and AI utopianism, because I think there's a bias that people will think something of a great intelligence will come in and be a kind of a steward for humans and help us to evolve. But I think that something like AI or another race of beings will just as likely, or if not more than likely, actually be hostile to the less intelligent. Similar to how you see clever people behave to. Well, a good example is humans are more. Roughly, humans are more intelligent than animals. We're not necessarily more moral and ethical. Enhanced intelligence doesn't correlate with enhanced compassion and kindness and moral and ethical reasoning. So those are one of my concerns. And I think, but on a more kind of benevolent note, one of the most futuristic ideas in transhumanism and futurism, particularly in something like bioethics, is the abolition of suffering. And I think to achieve something like that, something so lofty, I think the idea of a benevolent dictator or a benevolent digital panopticon would be a job best suited for something like an AI, if it doesn't destroy us or think of us as some kind of infestation. But I do agree with what Donald said. I think it's either a long way off or kind of impossible, but we'll see. Thank you.
Thank you. This is really great discussion for our audience. I directly want to go for the concluding remarks. Before that, I just want to share tomorrow we have our debate. We have our world famous debaters. So I don't know, like if we change our parliaments like aside, let's say Professor David Smith will be Prime Minister for tomorrow, and Professor Rob will be opposition leader for tomorrow. So we just change, give some chances to our Honorable David Smith. And
What's the
yes,
topic?
topic that internet should be regulated.
Oh, so David Smith's going to be pro internet regulation, and I'm going to be con.
Yes.
Okay, I'm good with that.
Okay, that's why. Yes, and you know, the last week we do debate education should be free. So yes, we are getting very good response from around Asia Pacific. Even the good news is that today we finish our meeting with Honorable Prime Minister Office Beza in Bangladesh, and they are very happy with our work, and they are interested to uh, like share this island for our dream projects, for university projects. Bangladesh Prime Minister Office, like even some corporation, they show their interest. They want to support our initiative. Even any people, even definitely our honorable speaker, they are our board of advisor. Uh, I'm sure they will enjoy to teach the peoples and the new generation of Asia Pacific. So definitely, I want to, and our people want to see everyone, those who are speakers, those who are our board of advisors in Asia Pacific. Maybe we can build up a successful university, because education solution is our key from World Talent Economy Forum. Besides that, even from India, I share with our speaker that even one of the king, he has a big palace. He's very happy to welcome all of our speakers with the university projects. That is the beauty of developing world. We help each others, and definitely develop nations. They have their knowledge. Our speakers, all of them are highly knowledgeable, highly influential. So if we march together, if we work together, I'm sure we can change millions of people's life. So that is our objective, World Talent Economy Forum. We are doing hard work with our teams day and night. Many people doing lot of sacrifice, but hopefully all of your sacrifice will be very, very valuable resources for the global communities. And we are really, really happy how we getting response from Prime Minister Office, from kings, from good corporations, from academy, and definitely our speakers is our asset. Our board of advisor is our asset. So if we work together, definitely we will rebuild this new world with our knowledge, with our expertise. So thank you, Honorable Professor David Smith, Professor Rob, Professor Donalds, as well as Mr. Adam, for your continuous support. And I want to give thanks to our audience, because you are the key. You always support, you always share our content, you always share your problem and challenges. So hopefully it will be the new revolution from Asia Pacific. So thank you, everyone. Hopefully everyone join for tomorrow debate. This debate will be very effective for everyone. And soon we will arrange a debate with the real parliament member. Definitely our speakers gonna attend in the debate. So thank you, everyone. I directly want to go for the concluding remarks. First, I want to give just Professor David Smith.
Sharif, love the discussion today and how it's headed and what's being done. If you could pull up the slide for me.
Yes,
That's in
sure.
the slide. We talked earlier, and Rob and I both talked about how IBM's one of the leaders there. Deloitte is one of the other leaders in looking at trustworthy AI, and they put in place a framework to use. And what's interesting to it is we talked about many of the things in the big part of the circle. AI has to be fair and impartial, robust, reliable. Privacy has to be there, has to be safe and secure, and responsible and accountable, and transparent. But you begin to then see in the lowest parts of the spokes, there has to be an AI governance in place. So if it's a government agency, if it's a company beginning to use AI, particularly very broadly, there has to be AI governance put in place. And then you see the circle with regulatory compliance. Many organizations today are putting in quite a bit of regulation, both in company levels and actually in state levels now and national levels to have regulatory compliance. And that regulatory compliance is something that we're a little bit behind on, but is really beginning to come and being put in place. And I think you'll see more and more of that as we come out there. For example, the United States Department of Defense now has multiple regulatory frameworks and regulatory initiatives in making their artificial intelligence trustworthy. I also want to say that in some ways, Donald is correct that AI has a human genesis to go to it as you begin to go autonomous. But what I have seen, particularly in some of the very, very large scale artificial intelligence systems that I'm familiar with, in places like large network operating centers, in Department of Defense systems, and others like that, many times the decision making will change as the machine learning goes into the system. And you'll see rules change, decisions and paths change based not on the human rule, but how the machines have adopted that over time. And particularly in the systems like the financial industry, network operation centers, and in departments of defense, where these decisions have to be made in microseconds and things, you see that type of automation going on where you have to build trusted AI in there and understand the nuances of it. You know, we all heard the story a couple of years ago where Google built an AI system that was self-learning, and they ended up having to shut it down because the decisions it made going down the road, for example, one of them that humans were bad, were things that had to be reckoned with and taken out of the system. But artificial intelligence is here to stay. We're seeing it everywhere. You know, you can almost not call a corporation today without going into AI chat boxes. If you want to do customer support, customer service, you're running into AI that has to adapt to a wide range of circumstances. And so this is an excellent topic, one that still has a lot of work to be done on. But the fact that we're beginning to have frameworks put in place, we have governance being put in place, and we have regulatory activities being put in place with it, tells me that we're moving well up the S curve to go towards that general intelligence that Rob talked about today and Donald talked about and we've talked about in the past. That is where AI goal is to be. We're not there yet. It's going to take a while, but this is an excellent topic, Sharif, and thank you so much. You're muted.
Professor Rob, what's your concluding remarks for today?
Sure. We were talking about a series of very different taxonomies on how we talk about AIs. We started off with the narrow versus broad and had a couple versions of that. There's another taxonomy I like a little bit better. It defines AI in 4 categories: reactive, limited memory, theory of mind, and self-aware. Right now, we're mostly in the reactive stage of AI. These are AIs that can take in a certain amount of information and either make a decision or make a recommendation based on the information it takes on. Limited memory AIs is what we're kind of exploring right now with deep learning. And the conversational AIs that we see are to a large extent limited memory AIs. And they're pretty good. The advanced ones are surprisingly capable. IBM tells the story of a trial they did, and this was 3 years ago, with an insurance company, and the number of prospects that was used for sales. The number of prospects that attempted to ask the AI out in a date was both funny and compelling. It successfully fooled folks into thinking that it was human. And we've had AIs pass the Turing test for about a decade now, a little over, I think. And so AIs can now convince you, at least with vocal responses, that they are human. Though in most cases it's creative at how they do it. The next one for us is theory of mind, and this is really where I think a lot of the development is going to be focused for the next few years, and that's where an AI understands the needs of other intelligent entities, and by the way, that includes the needs of other AIs. And as we look at autonomous robots and vehicles, part of the architecture that's being deployed is a vehicle-to-vehicle or robot-to-robot technology. So they're in constant contact and they are negotiating on an ongoing basis, kind of in a sort of hive mind, as to what the decisions should be made by the group or by the individuals in the group. That's really kind of interesting because it kind of suggests that at some point we may reach the theory of mind AI, not in an individual AI first, but in a collection of AIs operating cooperatively. And then finally, the self-aware AI, and the concern for a lot of us in the self-aware AI, which is where it has a human-like intelligence and self-awareness, is the fact that we may not be able to detect when we get there. We have a very narrow definition of intelligence, and it tends to revolve around how we perceive ourselves. In other words, we view anything that's human as intelligent, anything that's not human is not intelligent. And the exception, of course, is recently, I believe, octopuses were categorized as an intelligent species in Europe. And once again, we probably should have determined that a long time ago, because they clearly can use tools. They can walk up to a problem they've never seen before and solved it. And there are quite a few animals that are capable of doing that, performing either rudimentary or advanced intelligence. In fact, one of the scary things you can find on the web is they put a bird in a reactive cage, fish in a reactive bowl. Sorry, I mixed up my species. Fish in a reactive bowl, and with a little bit of training, and they put it on wheels, and the fish started problem solving. And moving around as the effective brain of the robot, which suggests we are nowhere near where we need to be in terms of being able to identify and classify intelligence, which takes us back to an ethical problem, the ethics problem at the core. If we can't really define and identify intelligence, how in the world can we come up with a set of ethical rules that will define or control that intelligence going forward? And that's a really difficult question to answer. I believe David brought up the case where in one of the trials, the AI determined that humans were the problem and we need to eliminate them. But that might have been the right answer. If you put an AI on something like global climate change and suggest what the major things you could do to have the biggest impact, I almost bet you money that one of the first things it would come up with is eliminate the humans and the problem goes away. Because it wasn't until humans came about that we really had the problem. Even going back decades, if you look at Los Angeles and the pollution, they did an analysis of the pollution in Los Angeles years ago, and it determined that LA had pollution long before we had machines that from the fires that the native Indians had in the area hundreds of years ago. But once again, humans being the problem. So there becomes the issue. If we get a machine intelligence that reaches self-awareness and starts thinking about self-preservation, there's a high probability that it could determine that humans were the predominant problem it had to correct with regard to its self-preservation. It would act against the race. So that takes us back to the 3 laws of robotics that Isaac Asimov had, the idea of putting in place rules that control things that we fundamentally don't understand in a framework we haven't developed for a technology that hasn't reached its end goal. So we've got a real problem here. Because we're hell bent for leather in developing these things, but we're really not good at determining the rules that define our own behavior. We are really inadequate in terms of determining behavior of other things, whether they be animals and machines. And it very well may be that the only way we can solve this problem is creating an unbiased AI that can make the determinations on what would be ethically correct for the problems being faced. But as mentioned, that AI, if it was perfect, might determine that the way to fix the problem is to get rid of people. So it's an issue. The ethics is not an easy topic to discuss. It is one we've struggled with for generations, and we will likely struggle with for generations more. The danger here, though, is artificial intelligences can and do make decisions at light speed. And autonomous vehicles is the example of machines that act fully without human intervention. And as they get more capable, we do need to ensure that they don't become more of a risk than they do become a benefit. And particularly as we moved allowing these things to control large military installations, our financial system, and they are very active right now in our financial implementations and our infrastructure, is to make sure that there are controls in place that can step in case the AI, either on its own or because it's been compromised, acts in a hostile fashion.
Thank you, Professor Rob. Mr. Adam, what's your concluding remarks?
Thank you. I think with futurism and transhumanism, AI makes a very compelling and interesting thought experiment, and it's very exotic and far out. And of course, we don't want to lose sight of our more grounded, immediate, and near future issues to try and solve, like anti-aging, life extension, involuntary suffering, mental health. These goals are not mutually exclusive, of course, and they might even be mutually beneficial. But I do understand the appeal of achieving such a marvel from a Promethean perspective. We could even say it has a kind of Faustian allure. It's like how we can still feel celebratory and congratulate people like Musk for having the vision to venture out to Mars and the moon again, whilst not losing sight of problems that desperately need solutions like poverty, hunger. We are hybrid thinkers, so we can support two wildly different endeavors of even wildly different levels of urgency and moral weight. And AI could help open up the exploration of consciousness, maybe answer some of the philosophical puzzles that humanity has been preoccupied with, like how can we determine whether or not something else is self-aware, conscious, sapient, sentient, beyond I think, therefore I am, and solipsism and all that. So yeah, those are my thoughts today.
Thank you. Professor Donald?
I want to close up by just basically throwing out a few puzzles that I think are worth thinking about. For one thing, what is self and what is consciousness? Self is basically stories that you tell yourself that explain what you do. And other people's selves are stories that you tell yourself to explain what they do, to make sense out of the world around you. And there's no place in your brain where there's a self. There's no place in your brain where there's consciousness. Consciousness is an epiphenomena that is something that happens from the interaction of all the different parts of your brain. You have to ask the question is, how is it that we get these stories? Where do these stories come from? And partially they come from our experience, but mostly they come from our social environment. I'd like to suggest to you to think of 3 things that you get that are important in life that you don't get from other people. It's a very difficult, in fact, I've asked this question in front of audiences many, many times, and basically people can't come up with it. Or they come up with really lame ones like masturbation or something. And that's who we are. We're created by the social environment that we live in. How language doesn't have any, it's not something that's by itself. Language is something that's part of our human interaction, and we're forward looking. So when you're listening to me right now, there's probably a part of you that's thinking, or many of you that's thinking, or listening to all of us, there's part of you that's thinking, well, how can I use this information? What'll it do in my life? What'll it do in the research that I'm doing? How can I use it? Everything, when we talk to each other, we're future oriented, because that's the way our brains work. We know now that our brains are not, that we don't get sensory data, and based on that sensory data, we do things, or we basically feel or experience the world around us. What our brain does is it creates a model of what is going on around us, and the sensory data allows us to update this model. And so it's nice in theory to imagine that we could make those models, but when you get into something like theory of mind, a lot of the theory in mind has to do with, it's basically, I'm guessing what you're going to do. I mean, I'm deciding how I'm going to interact with you because of my understanding of what it is that you're going to do. And that's this important forward-looking aspect to us that modern neuroscience and psychology is really starting to take for granted. And so I wouldn't think, I don't see how I think that saying, well, machines are going to develop an intelligence by talking to each other that's more or greater than us and all this kind of stuff, I think that's cheating. Because the guy who came up with the idea of the technological singularity was an absolutely brilliant science fiction writer, one of the best who's ever lived. His name is Werner Vinge. He got 5 Hugo Awards. Brilliant guy. But he's a science fiction writer. This is just something that a science fiction writer thought up. There's nothing that we're doing that makes it close to being able to actually start having any sort of general intelligence. We're not even anywhere close, and we have no idea how to even begin. On the other hand, I mean, and plus when you see these language things, they're cheating. Like the reason it could win Jeopardy is because it had Wikipedia at hand, and the answers to Jeopardy are very often the titles of Wikipedia entries. That's how it won at Jeopardy. It doesn't know anything. And so I suggested to take a sentence like, Mary said Mark, Sally's friend, didn't think it was important. Mary said Mark, Sally's friends. What happens is when it starts running into a series of names in a row like that, it can't figure out the embedding. And I'm just, it's early in the morning and I didn't get much sleep, but I can always find sentences that will blow it out of the water that are trivial for human beings. And we can't write the rules because there's an infinite number of sentences. We can make an infinite number of sentences. So somehow the system can't just be recognizing patterns like strings. It has to somehow be able to actually understand how it is that we make and generate these sentences. And when we're making them, when we're talking, we're referring to things that are in our environment and inside our head. And as I pointed out, even something as simple as a chair is actually incredibly complicated, but yet a 6-year-old knows what it is. So that is I think not a real worry. But what I'm saying about using this information to make decisions is something we have to be very, very careful about, because we don't know what these things are doing, and they can be doing it wrong, and we have no way of really looking at what it's doing, like we could do with an algorithm where you could put it into debugger if it was in C or something like that. You can't do that with these. And so we don't have any way of like testing to see if the algorithms are working correctly. So we need to be very cautious of that. And I think that the best thing is important, goes back to what Adam was saying, is that things like clear thinking, being able to solve problems, being able to use our human ability to make connections between disparate things. I mean, that example I gave, a 6-year-old kid putting a blanket over a chair to make a fort. I mean, that's brilliant. But yet that's what humans can do. That is going to be a long, 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 long time till any sort of machines can be able to do it. But so we can work with that artificial intelligence, with the pattern recognition and all the wonderful things it does, but we always have to stay a step ahead of it. I mean, in the sense that our own thinking has to recognize what we're really good at and integrate the ability to recognize these complicated patterns that are bigger than we could recognize, but then take the information we get from that recognition and then using our own human ability to be able to do something with it. And so, yeah, so that's what That's what I want to say. And it's always wonderful talking with these guys. They're so special to me. So thank you, all of you.
Thank you. Thank you. Thank you, everyone, for joining today's sessions. See you tomorrow with our debate. And for tomorrow's debate, Professor David Smith will be Prime Minister. Opposition leader will be Professor Rob. So, Professor Donalds, you can take your part. Mr. Adam, you also can attend in the debate. You can choose your leaders. Okay, you can go for government or you can go for opposition. So, thank you, everyone, for joining today's session. Thank you. Bye bye and take care.
Bye. See you next time.